Good evening, all of you. Today we are going to see about torque. Torque is defined as the moment of the external force about a point or axis of rotation. So torque is a vector quantity. It is represented by tau is equal to r vector cross product with f vector. So this means it's a cross vector product. So now we have two cases. Assume the point of interest is here and this is the reference point. R vector goes in this direction. The magnitude of R vector is this much and force is applied in this direction F vector. So one thing you have to keep in mind is whenever you do cross product, see that if this is going to be the point, two vectors are placed like this and this is the angle. But if you see here, this is not of this form. Okay? Just carefully watch. From a point, these two vectors are directing outwards. So what you do is, since this vector is going in this direction, it continues to go in that direction. So you just draw the same magnitude here also. So this length and this length or the magnitude are same. So this is R vector. Now the formula for torque is R vector cross product with F vector. That means R vector is acting on F vector. That means it is anti-clockwise. So when it moves anti-clockwise, the resultant will come in this direction. That means when R vector cross product with the F vector, this is hitting like this. So it moves in the anti-clockwise. Just remember, when you unscrew something on the board, so when you unscrew anti-clockwise, the screw will come out. So similarly, R vector cross product with F vector, this is hitting on F, so it moves in anti-clockwise. So assume this is the point of screw, so the screw will come in this direction. That means the resultant torque will come in this direction. Okay, so that is case 1. Suppose in case 2, this is the reference point and the point of interest is here. The distance here is R vector and this direction and the magnitude is this much. The force is acting on this point in this direction. Now again I already told you, whenever you do dot product or cross product, you have to keep in mind that the two vectors are moving away from that point. So what you do is, this vector is moving in this direction, you just project in the same direction. So this is R vector. Now the magnitude, so this length you keep here also. Okay, that will be the magnitude. Now R vector is in this direction, force vector in this direction. The point of interest is here and the angle between them is theta. Now torque is what? R vector cross product with F vector. That means now R vector is hitting F vector. That means it is moving clockwise. So assume that a screw is here. With a screwdriver, if you try to rotate clockwise, what will happen? The screw will go inside this board. So therefore, the resultant torque will be just penetrating this board and goes inside. That means all the three, that is R vector, F vector and tau vector, all are perpendicular. Understood? So this R vector cross product with the F vector and the resultant tau vector is perpendicular to these two vectors. So that's how you have to remember. So to state simply, Suppose if you have something like this, assume this is point of interest r vector and this is f vector. So of course it is 90 degree. Now this r vector is hitting on here. So this will move anti-clockwise. The resultant will go in this direction. Now in this case, since this is 90 degree, all are mutually perpendicular to each other. Suppose if this is r vector and this is f vector, from this is the point of interest. So this will is in direction and this is in this direction. R vector cross product with f vector. So this is going to hit this. So it is clockwise. So it is like tightening a screw. The screw will go inside like this. So the resultant torque will be in this direction. Of course, in this case, all the three vectors are mutually perpendicular to each other. Now, carefully watch. Assume this is r vector and this is force vector. Now I already told you from a point both should go away. That is the easy way to remember. So this vector is going in this direction. So even though you are having a vector like this r vector with magnitude this much, just project the vector in the same direction with the same magnitude. Now you will be getting r vector. Now r vector cross product with f vector clockwise, so it will be penetrating inside. It goes down like this. That will be the resultant torque. Hope you have understood the basics of torque, which is defined as the moment of the external force about a point. So the point is here, or axis of rotation. So it can be axis also. But here I have dealt only with a point, taking a point as the reference, and I am interested in finding out the torque. Thanks for watching this video. Nandri.